All right, on to the next one, human events and the environment. So we've talked a lot about human events. Like a big example is Chernobyl, and we'll talk about it again. And we've talked a lot about the environment, so we're just going to put it all together here. So the objectives are to evaluate the impact of different agricultural techniques on the environment, and we're going to describe the effects of large-scale environmental catastrophes. So, some agricultural practices we'll talk about are tillage, which is working the soil to prepare for crop production. We talked about tilling quite a bit. The birds in the California marshlands that they till, and then just, humans do it all the time. We're going to talk about pesticides and herbicides, irrigation, and fertilization. So all these things should be a little bit of like renewal. You've already learned about these a little bit. So tillage is just movement of materials in the soil. We're just making the bottom part of the soil come to the top, essentially. So one thing like that can happen is the soil can have pollutants in it, and they'll be on the top. And so when you till that soil, it's going to put the top of the soil on the bottom, and it's just kind of rotating the soil. So that top of the soil that had pollutants in it is now on the bottom. And so the pollutants are just going to kind of stay in the soil for until, water or something comes through and gets them out of there and puts them in another system. So tilling can change the properties of the soil. Erosion is a big one. So that's going to lead to air and water pollution. With more erosion, there's going to be more dust particulates that are able to go into the atmosphere and the water, and that's just going to pollute both of those systems. We get soil loss with erosion. So sedimentation, it's going to deposit rock or soil into bodies of water. Sedimentation, as you guys know, is when erosion happens and then that sediment ends up being deposited somewhere. That's what sedimentation is. That's the process that we're talking about here. So sedimentation from tillage is kind of like we get this increased land usage for agriculture. It's going to result in increased sedimentation, aka erosion and deposition. The sediments are eroding, they're deposited in wetlands, lakes, rivers, estuaries, etc. Bodies of water. That's where the sediment is going from farmlands. Then after that, aquatic life is disturbed. It decreases wetland functions, and I could have 15 units on wetland functions, especially if I'm from Michigan. We know all about wetlands. They're really good. They stop floodwaters. They are natural, like pollutant cleaners. They have a lot of niche species. A lot of tourism is involved with those. Wetlands are amazing. They do a lot more than people think about. And so here is just tilling. So on the left here, we've got a conservation tillage system. So there's no till residue surface. Essentially, they go over it less than they go over it with conventional tillage. So conventional tillage, they're plowing the surface, and then they're burying the residue underneath of that plowed surface. And that's that accumulation of pollution that we were talking about. Tilling is necessary to kind of recycle nutrients in a system, but when we put too many nutrients in the system and too many pollutants, then that's just going to cause burial of pollutants and fertilizers and pesticides, all sorts of stuff. So let's get into pesticides and herbicides. So ecotoxicology is the study of pollutants in their environment, their origins, and their effects. So there are people that look into this. They're really, really smart people, and they make sure that, pollutants aren't totally destroying ecosystems, and they're trying to figure out where those pollutants come from. And this ecotoxicology kind of came from the DDT era that I was telling you about, and how, the birds were laying eggs that had really thin shells and basically created the epidemic for like osprey and bald eagles back in the 60s and 70s. So that's where ecotoxicology kind of came about. We needed someone to figure out what the heck's going on, where is it coming from, why is it happening, that type of stuff. So herbicides are compounds used to deter unwanted plant growth. So herb and then icide, this is death. So herbicides kill herbs, plants. So a good example of that is glyphosate, and people normally call it Roundup. That's a Monsanto product. Glyphosate is totally safe for humans. It only affects plants. It affects the plants physiological energy cycles. So we have completely different energy cycles than plants do. It is completely safe. Glyphosate, aka Roundup, is a safe compound. So when people talk about Monsanto as an evil corporation, they're talking about it for the wrong reasons. They are pretty bad. They have a monopoly on a lot of farmers. They really destroy diversity for farming communities, but the glyphosate that they've got isn't some sort of conspiracy to like control your mind or anything. It's totally fine. I've done a lot of research on glyphosate. So let's talk about degradates. Degradates are the products of the breakdown of the original pesticide or herbicide. So that pesticide or herbicide is going to get hit with water normally. It's going to turn into a solute, which is just a simple term for saying that water and like a certain chemical mix together, and then that water breaks apart that chemical. And so that breaking apart of that chemical is going to create a degradate. And then degradates can have similar qualities as the original compound, and they can stay for a long time in soil, especially when we're tilling it the way that we do. So what's going to happen then is we're going to get runoff into streams that can eventually make it into large bodies of water. And it's always going to happen. If you put something in a stream, it will end up in a large body of water. That stream goes somewhere 100% of the time. It just might take a while. So here is a little illustration of people applying pesticides onto grass. You can see they've got protective equipment on. That's just because the pesticides that they are applying, are in such higher concentrations than what we're going to receive as the end product that they really can't. It forms a health hazard for them to take that in. That does not mean that this is unhealthy for you to consume. It's going to be a lot less on these plants than if these guys were just sucking up this gas right in front of them. It's a lot more than what you're going to be receiving by just eating some rice. So another agricultural practice is irrigation. So irrigation is normally with reclaimed water, aka bath water and sink water. And so there's a big thing from the government basically that said don't flush your pills down the sink. And the reason why is because we use this irrigation to like basically water our crops. So if you put a bunch of pharmaceuticals into the sink, that's going to go into the reclaimed water that we're using for irrigation, and it's going to be deposited into the soil. So do not put your pharmaceuticals in the sink. Throw them away in at normal facilities that are used for that. We have facilities that take pharmaceuticals in. So do your research. Don't pour them down the sink. It's going to go right back into the soil, and then people are going to have all sorts of weird things going on with them. So these pharmaceuticals can also accumulate over time and be distributed into water sources through sedimentation. So you know that tilling has, it kind of coalesces with the irrigation, and it creates this horrible problem if we have pharmaceuticals in the soil. So here's just irrigation. They flooded this whole area up. They used water from reclaimed sources to irrigate the crops. So then we've got fertilization. And fertilization is essentially nitrogen and phosphorus. We've talked about this before. What's going to happen with this is that both of these are soluble/insoluble with water. So one goes into the water and will go down into a runoff zone, and it will end up going into lakes or the Gulf of Mexico. And then the other one is insoluble with water, and it's kind of like oil that just slides across the top of the water. It's going to do the same thing. It's going to end up going into large bodies of water. So the dead zone that we've talked about many times is the Gulf of Mexico. That's a big example of that. A lot of our fertilization is going from farmlands in the middle, the heartland of America. They go into certain rivers, mainly the Mississippi, but they're all in all sorts of tributaries going into the Mississippi. Eventually that goes all the way down into the Gulf of Mexico, and now we've got this increase in algal blooms, which increases the amount of bacteria in the system, which lowers oxygen in the system, which causes a massive amount of death for fish and other plant species in the system. So that's why we call it a dead zone. It's literally dead. Nothing can survive there other than algae and bacteria. So Lake Erie in the 1960s, I used to live right next to Lake Erie in Michigan. The 1960s, Lake Erie showed signs of aging because it had a phosphorus overload from farmland runoff. It caused an increase in algae, which caused an increase in bacteria, which lowered the oxygen in the system, and it killed a bunch of fish. It changed the aquatic life of the ecosystem, and kind of really cost a lot of money for them to rejuvenate Lake Erie. And it's still not rejuvenated, but steps have been taken since then to rejuvenate the lake. So here's Lake Erie. Here's all of this gross runoff that we're looking at here. This river right here actually caught on fire multiple times in the 60s, and no one could figure out why until some scientists got together and told them, hey, you're dumping stuff into the water, and of course it's going to catch on fire. So here is just how phosphorus and nitrogen runs off from farmlands. All this green area is farmlands. It follows these riverways. It goes down in the Mississippi River, goes all the way down, and then we've got this huge 5,000 kilometer dead zone in the Gulf of Mexico, which was normally a very productive system, has a lot of economic ties. This area down here isn't doing so hot because it's a fishing area, and they have no fish. So, environmental catastrophe impacts. What happens with environmental catastrophes? Well, plant and animal life is killed or displaced. We get changes to the Earth's surface. We get desertification, sea level rise. We get air quality issues like smog, water quality issues. They become polluted or unusable, and that's going to contribute to drought. So, if you're polluted or you have polluted or unusable water, then that is a non-renewable resource. It cannot be used, so it contributes to drought. So with plant and animal life, species can become threatened, endangered, or extinct. So threatened plants or animals are expected to become endangered. Endangered ones are plants and animals that are near extinction, and extinction are either gone from an area or gone completely. So there's kind of a difference there, but we, in this world right now, have 10,000 times the natural rate for extinction. So think about that. We're in a mass extinction event, and we're not doing a whole lot to change that. Some things that cause these extinction events are deforestation and habitat loss. A good example is our great apes. Oil and chemical spills really screw things up. And then this will change the food web, and that can cause a total collapse. So here's an oil spill. This pelican died. It just can't come back from that. Here's a sea turtle that most likely died as well. It's just stuck in oil. It's breathing that stuff in. Here's deforestation. This koala's got nowhere to go. Neither does this orangutan or this tiger. And these are species that we see are endangered and are on the brink of extinction right here. So think about it. And then we've got the food chain here. So imagine if this large shark becomes extinct. What's going to happen? We're going to get more mahi-mahi. They're going to have to eat, so they're going to eat more mackerel. There's less mackerel, so then there's going to be more of these little fish, and then there's going to be less zooplankton, which means there's going to be more phytoplankton. So these systems get really screwed up when you take out one species. If one species becomes extinct, then the whole system starts going crazy. It's kind of a positive feedback loop where it becomes unstable. So just think about that as well. You know, if you take out the phytoplankton, the whole system dies. So, you know, it's just things to think about. You can take one of these out and the whole system gets screwed up. So we've got changes to the Earth's surface. Land temporarily or permanently is damaged or changed. A good example is the wetlands in Iran or Iraq becoming arid deserts after they like blew up a lot of oil in that area and it destroyed a lot of the wetlands. Land usage has changed, so glacial melting is going to cause a rise in sea level, and the massive Antarctica is decreasing tremendously. So here, this is before, look at all that wetland, and this is after, in 2000. No more wetland. And this is basically due to Saddam Hussein and our first Gulf War. And then here is the Antarctic ice mass. It's just going down, and this is going to contribute to global warming and a rise in sea level. So, air and water quality, polluted supplies become unstable, polluted water contributes to drought, we talked about that. Aquatic life is disturbed or destroyed, like coral reef bleaching. Global warming increases in atmospheric CO2, increased temperature and water changes. Chernobyl, we talked about this before, it changes everything. Animals are just now starting to come back after 30 years of cleanup in Chernobyl. We get a lot of increased mutation rates, which mutation leads to cancer a lot of the time, so people around there are dying. And here's just another good picture of coral bleaching. This had a bunch of organisms, this has none.